So another form of loop is the for loop. And let's look at the flowchart for when we did this with a while loop. So with a while loop, we did this thing where we get number of hellos, we did a count, and we looped a certain number of times. Um, and then we printed hello for each instance, and then we said goodbye. We can do the same thing with a for loop, and in fact, a for loop is probably better for that use case. So let's do a demo. Let's call it for loop demo 1.py. And one of the things that can be useful for this is, well, let's do this first. Let's say that we're going to loop 3 times and say hello. So with the for loop, like a while loop or an if statement, you have a statement between the for and the colon that is going to govern how your loop is going to function. Instead of a Boolean expression, though, with a for loop, you create a variable name, anything you want. And so num in, and I'm going to create a list of numbers, 1, 2, 3, 4, 5. Or 3 times. So we'll just make, and what we're going to do is we're going to print hello. And let's run that. And there you can see. So what's happening? Well, let's put a breakpoint here. And where does num show up, and what is it doing with this? So I'm going to run this in debug mode. And for that, we can start debugging F5, and here's our breakpoint. So I'm going to run in debug mode. I'm going to pick the Python. So here we are in debug mode. We've stopped at step 2, and let's look at num and what it currently has. So if we hover over it, don't have anything yet. I'm going to step over 1, and then if we can hover over num, we can see that it has a value of 1 at this point. And that's because num has taken the value of the first element in the sequence after the in operator. So what's going to happen with the for loop is each element of this sequence will be placed into num, and then it's going to execute. Now right now it's not doing anything with num in this loop, so it's just going to print hello. So I will step over one more time. We get our first hello. Num is 1. I'm going to step over 1 time, and now num takes the value of the second element, and we print hello. Step over again, we get our second hello. Num is currently 2. We step over again, and now num is 3. It's taken the third element, and then it prints hello. We're back up. Num is 3. We step over, and we can see that we're done because we've exhausted the elements in the sequence, and it's taken each value. So maybe what we'll do is after the loop, we'll say goodbye. And note that, and then we'll print out num so we can see it as it's running. So I'll make this a format string, and we'll put this in here. And so now it's going to display it. So let me just run it with Control F5 just to run it not in debug mode, and see what happens. And we can see we have hello 1, 2, 3. Note that it doesn't really matter what things are in here. It's just going to take each one and place them in that num variable. So if I run this again, you can see every element of the sequence is going into num. In fact, it doesn't have to be a list. It just has to be some sort of sequence here, and it will take each of these values in turn. So this works nicely. And going back to our previous example, 1, 2, 3, let's say we'll put 5 things in now. if we wanted to do 5 things and we wanted to have the consecutive numbers, we could do it this way. And we can see, okay, that works great. But what if we wanted to display 100 hellos? Well, that would be kind of problematic because, writing, go ahead and write 100 numbers in here and I'll wait. Okay, not really. That would be painful. And as programmers, we don't like painful things. So what we can do is we can actually do this with this function called range. And what range does, it returns an object that produces a sequence of integers from whatever your start number is to your stop number. And notice it's also exclusive, inclusive. And so let's do 0, 10 and see what we get. So we're going to go from 0 to 10 and see how that works. And it worked. Note that we got the 0, so that was inclusive. We didn't get the 10. We only got the 9. So that's exclusive. So just like when we are doing a slice, we get from the beginning to the end. And in fact, you can kind of do the same. You can do this too. Let's see what happens if we just put range 10. We get the same thing. And so if you don't put a start, it assumes 0. You can also do things. Let's say we want to go from 5 to 10, and we want to do every other one. So the same kind of rules that we learned when we were slicing lists works with range as well. And you can see that we went from 5 to 10 in steps of 2. And, you can do many of the same things. If you want to go backwards, we could go from 10 to, say, 3 in minus 2 steps. And this will count backwards. So we can use range with num to kind of step through things numerically. We can also step through a list. So I'm going to put this one in as for loop demo 1, and then let's make for loop demo 2 .py. Actually, I'm going to place this here. I'm going to go Control Z a couple times so that I go back to when we were using so this one I'm going to rename as for loop demo over a sequence. Kind of a long name, but it helps to see what's going on here. So this is going over a sequence. This one, which is where we ended up, is using range. And the typical way you're going to do this is 0 to some value. We'll put it this way so that we have we can see all the little pieces from the beginning to the end in steps of 2. And then let's see. We can also do some things with for loops with parallel lists. So let's make a new file and we'll call it for loop demo parallel sequences. And let's say that we have names is equal to Cecil. Need these to be strings. DD and Earl. And phone numbers. Make another list. 1, 2, 3, 4. And then next one will be 2, 3, 4, 5. And next one will be 3, 4, 5, 6. So you got these numbers, and then email addresses. Cecil at aserver.net. DD at aserver.net. And Earl at aserver.net. So we've got these 3 email addresses, and we have these 3 phone numbers. They're all lists, and they're all parallel. That means if we have the index for Cecil, it'll apply to this one and this one. And so we can actually iterate through these a number of ways. One is we could say for index, or we'll just say I, in range, and we have 3 numbers, so we'll say range 3, and then what we'll do is we'll print, and we'll use format, and we will print I, comma, names, index with the square braces I. So we're going to get the element at, I'll just put spaces between these. So this is not going to print all of names. It's just going to print the name at the index which I currently has. And then we can put phone numbers at index I. And then we can put email addresses at index I. So we're using the index, the square braces, to grab the one at whatever I is. So let's run that and see what we get. Okay, we've got this weird square brace here. I don't need that there. So I'll get rid of that. So that made this square brace here. Let me run it again. And this works kind of nicely. Here's the index number, here's the name, here's the number, and here's the email address. So if we want this to be a table, we can put a colon, and we can put how many characters we want to use. So let's say that we'll put 20 characters for the name, phone number is 4, so we'll make that 6, and then we will make the email address be 30. Let's see if this works. So we can set the width by using this nomenclature here. Let's say that we want the first one to be justified against the left, and take maybe 5 characters for the index. And then names we want to be right justified, and we will use 20 characters for that. Oh, actually that needed to be out here. And then here we wanted to use right justification and 6 characters because it's 4 characters for the number, and that leaves some space around it. And then here we want to be right justified, and they could be kind of long, so we'll put 40 characters here. So now what we've done is, in this loop, we set it up so that this will display in a little bit of a table. And we can see, okay, maybe there's some things we want to change. Maybe putting names on the right looks kind of weird. So we'll change it to left justify. And these are short names, so maybe 10 characters would work better. And then here, again, I think also maybe we want everything to be left justified. It kind of looks, I think, more consistent. And we'll try that approach. So you can play around with these. And note that this has to come after the variable that you're displaying. And, okay, that looks like a pretty decent table. And we can also do something like this. We can use kind of the same print statement. And rather than displaying that, we could just put the number sign character here. Put name as the header here. And so I'm just replacing this with the actual string element that we want. And then this one will change to email. And that will make a nice header for our table, hopefully. And we can see here now we have a nice headers that are perfectly aligned with this. So we could have just printed this out. So for example, we could have done this, print, and we could have just said, okay, well, I'll put a number sign here, and then I'll put number spaces, I'll put name, phone, email, and maybe I could have made my header this way. But what you'll find when you do that is you kind of have to go back and forth, and if things change, it's kind of problematic. And you can see, okay, this isn't aligned, so I could add 1, 2, 3. Let's try that. Oh, phone's still not aligned. Put one more under phone and try that. You can probably predict what's going to happen next. Oh, my email's off. Let's go this way. And eventually you'll get your table to line up. But when you're using these format strings, instead of doing that, we do this. If we use the same numbers, and note that here instead of putting format string will anything that's in the curly braces, it'll render that. If it's a variable, it'll use the variable. If we just put a literal string in here, it'll just print out that little string. So here we see we have a series of literal strings. They have notice I put double quotes on the outside and single quotes on the inside. And then what happens is that in that same spot, email will go that later on we use email address at index 1 to be positioned. So these will now line up. And so this is a nice use of a for loop. We have 3 lists that have everything that we want to display. They're parallel, and we can loop through it without having to say, print names at 0, names at, and then names at 1, then names at 2. So, if we have a really long list, and later on we'll learn with files and databases that we could have some extremely long lists, this is a way for us to programmatically say, print everything in these lists and position them in this manner and format it in this manner. And so this works, quite nicely to organize a table. And so you can see that each of these tables is really a column in the table. So parallel sequences, whenever you hear the word parallel sequences, just think table, because that's really kind of what this produces. Now let's say that we wanted to show the user a 1 to begin with rather than 0. We could just change this to I plus 1. Just do a little math right in here, and it will add 1 to that index number, and it will work fine. Note that we want to do that rather than doing, say, this. If I went from 1, 4, so it would be 1, 2, 3. If I did that, what will happen is it'll mess up the indices where it's actually looking things up. So often, and you can see we start getting errors because we start running out of, we get index out of range because now it's looking up for element 4, they're not here. And sometimes people will put like an empty element at the beginning of their list. Don't, just keep your range, when you're working with ranges, just keep them 0 based. And when you want to change the way it looks to the user, change it just by adding a +1 in your output. It's much easier to deal with it that way. So that's iterating over parallel sequences with a for loop. So that's lists or any sequence. This could even be tuples. In fact, I could change one of these to a tuple, and probably most likely if one of these was going to be a tuple, it'd probably be the first one. So let's change this to a tuple. And we'll see that that works too. So it doesn't really matter what kind of sequence, this will work. Another thing we can do is iterate over dictionaries. So we'll say for loop dictionary. And let's say we have a dictionary, and we'll make it a fairly simple one. We'll say from something like this. So the key are these strings, and the values are these numbers. And what we can do is say for key in the dictionary, we're going to print key, comma, corresponds to dictionary and then key. So what we're going to do is we're going to go through, and when we pull something out of a dictionary, what we get out of it when we use the in statement is actually the key, the first of these key value pairs, first element of these key value pairs. So first key will have X, then it'll have Y, and then it'll have Z, and then we will see the key displayed here, and then this, when we say dictionary and then put the square braces, when we pass a key to a dictionary, we get the value. So then this will be 1, 2, and 3. So let's see this run. And you see that works very nicely. So let's make this a little better demo. We'll take this information here, and let's make a better dictionary. So we'll do something like this. We'll say phone. We'll call it phone book is equal to, and we'll make this into a dictionary. So you can see all I'm doing is taking each of these elements and turning them into keys for our dictionary. So we'll do that, and then we're going to do the same thing, except for rather than name in a key, this is really name in phone book is now the name of our dictionary. Get rid of this one. We're making a better demo here. And then we will print the name, and so now what we're doing is we've named our dictionary phone book, and then we're going to go through and get each of the names out of the phone book and display the name. So this is the phone book is our dictionary. The key is name, and we're using square braces passing name to this phone book to get each of these in turn. And so when we run that, Cecil corresponds to that. And we can probably make this better. Let's turn it into a format string. And so we'll display name, and I'll put apostrophe S after it. So let's use double quotes at the beginning since we want to use an apostrophe. We'll say apostrophe S phone number is, and then we'll display phone book name, and then we'll put a dot at the end. So we make a nice looking sentence and close my double quote. So we have F, the double quotes at the beginning and the end. We use the curly braces with the variable, with the expression really that we want to see, because we saw we could actually use actual literals in here. But our expression is just going to be, hey, put name here and put phone book index name, here, which will get the value out of here. And let's see if that works. And we can see, yes, that works very nicely. And so we can also use sequence unpacking. So let's make another example. We'll call it for loop dictionary sequence unpacking. So we looked at sequence unpacking a while back. So I'm going to take this, get some of these closed up. Yeah, so we're going to take this example and do it with sequence unpacking. We can actually say name, comma, number. Well, let's demonstrate. Let's go through this whole process so you can kind of see what's happening here. So let's take the demo where we had x, 1, comma, y, and then its value is 2, and then the other key is z, and its value is 3. I realize keys and values can be anything, and it could be strings, they can be numbers for either key or value. So before we had this. And then we extracted the value out of the dictionary by passing it the key with the square braces, and we had this result. And okay, that works fine. You can also do this. Say key, comma, value, and d dot items. So what d dot items does is it will return each of these as a key value pair. I believe we saw items before, and let's just do this. Let's print, before we get into this, let's print d dot items. And you see it gives you a list of tuples. So when we say for each key value in d.items, what we're doing is we're grabbing each one of these tuples one at a time, and we're taking, and then we're sequence unpacking. We're taking the x and putting it here, putting the 1 in value. And then this, we don't need to do that. We can just put value. And you could see this is kind of nice because we don't have this indexing in here. We can print this with just the simple variables that have been sequence unpacked from this collection of tuples. And it works the same. And so let's see if we can, this is the example in your book. Let's see if we can do the same thing with what we had in this one. So I'm going to take this now, and then using sequence unpacking to do this, we have our phone book. And so we'll say name, comma, number, and phone book dot items. And then now here I don't need to do that. I can just put the number. So this, it's kind of nice because it makes this a lot easier to read and see what's happening. Oh, I'm displaying the name and number, and I'm getting the name and number from all the items in the phone book. So we like our code to actually read like a story if we can. And this, this is, here's our phone book. We're getting the name and number from the phone book items, which is, each item is the key, each key value pair. And then we're just printing them, and just print the name that you have and the number in this format. So let's run that and see what we get. And we can see that that works, just fine. It works very nicely. So here's another example of using a dictionary, and I'll comment that out. I think what's useful is also taking this and putting it in the, oops, don't want to delete everything. Putting it up here, and I'll restore this previous example here. So that you can associate them with the example in the book. So another useful thing that we can use in for loops are break and continue. So let's do a break demo. For loop with break. And so I'm going to do a loop. Let's say that we want to find the, we're going to do this. Find first number divisible by let's try it. Find largest number divisible by 3 between or less than 20. So you have some problem like that. Well, how can we do this? Well, let's go through numbers less than 20. And to do that, we would do a for loop for I in range 20. That should actually do it. Print, and we'll just print I just to see what we have. And it's a lot of times when you're solving problems like this, you just, you attack it from a piece at a time. So we're going to just try to display the numbers that are less than 20 first. And great, there we go. Now, if we wanted to find the first number less than 20, the largest number divisible by 3 that's less than 20, well, we better start at the end. And actually, just to make this more interesting, maybe we'll make it less than 25. Or no, actually, we'll just stay with 20. I think we're going to get to, 18 will be the answer. But maybe 22 would be more interesting. I don't want it to just run and then be done within one iteration. So and we'll maybe say divisible by 5. So we want to find the first number divisible by 5 that's less than 22. Well, how do we do that? Well, if we go in this order, and and if we did our test this way, say divisible or is divisible by 5 is equal to, and the way we can do this is we can take I modulus 5. And if that equals 0, and let's print I modulus 5 just to see what we get, then and then we'll print maybe just some dashes, and then we'll print is divisible by 5. And we should probably print I as well. So we'll print I. Some spaces. I mod 5. And then we'll just put spaces here. And then we'll run this. So let's see what this does. Well, let's see. Well, it is true that the 0 is divisible by 5. It is also true that 5 is divisible by 5. And we are finding the ones where we want to find the largest number divisible by 5 that is less than 22. And so we really should get 20 if we're starting at 22. So how do we get to that? Well, what we could do is we could, we could try to do some kind of logic where we keep going, keep track of the last one, and then when we get to the end, we take the one that was the last one. But actually, probably the easiest way to do this is change the step. So we'll go from 0 to 22 in -1 steps. And so I'll run that. Actually, we need to do this from 22 to 0 in -1 steps. So I have to flip these around. So now we can see that this is counting backwards through the list. And then it gets to, and you can see it at 20, the modulus becomes 0. That makes this expression true. So really what we want to do is we really just want to print this number. and then we want to stop there. Well, the way we can stop there is with the break command. So we used the break command before, and we're with the while loop. And so what we can do is we can say if is divisible by 5, break. And so we do this test here, and maybe I'll do that right here, so it's right next to it, so it's easier to see what's going on. So we're going to print the information, and then we're going to break at that point. So let's run that and see what that gives us. Actually, so I do need this in front of it because we're using it here. So let's put it back and run this. Okay, so we're getting closer because now we're only displaying, we're displaying all the numbers up to getting to here. So I think what we could do is we could say, you know, I don't really need to display this until I'm done with the loop. So let's see what we get here. If I were to, I break out a loop here, and then let's print what we got for I. And we can see, cool, we have, it actually just prints the number, the first number less than 22 that is divisible by 5. So what we've done is we're looping through. We keep going until we find the first number that's divisible. When we break out of that, I will have the value that is the one we're looking for. And so this is the utility of using break in maybe a loop like this, is if we're searching for something, once we find it, we break out of it, and then we have that index number that we can reuse. In this case, we're using it directly. And we could then make this into maybe a little bit of a more of an interesting program by asking, print or, display header, and then get number to search from, get divisible number, and then here we will display result. So this now becomes this. We say our header will be print. This program finds the greatest divisible number, and then what we do is we say upper bound is equal to, please enter the upper bound, and we're going to make this an integer and an input, and we'll tell them that we want this as a whole number, and then we get the divisible number equals, again, an integer input. Please enter the divisible number, whole number as well. And then we do our math, but now we use the values that are provided by the user. So this 22 becomes the upper bound. The 5 is the divisible number. I think we want to change this to, rather than 5, because it's not always going to be 5, we'll change the variable name to a more generic name. Got to change it everywhere though. So both these places. And then here we'll format this a little bit and say the greatest number divisible by, and we'll say divisible number less than upper bound is I, and then we'll finish that off. I hit Control Z so that at line wraps there's not really a character turn there. I sometimes do that so that you can see the whole line, and then that should be it. So we're going to tell the user what this program does. We're going to get the upper bound. We're going to get the divisible number. We're going to do that same algorithm we did before, only we're using these variables now so that it's a much more generic program. And, as soon as that number is divisible by the other, the modulus of that will equal 0. We're going to break, and this is what the point of this example is, to show you how the break works, and then it will display the value. So let's try running that. 77, and we'll put in 22, and let's see what we get. So the greatest number divisible by 22 less than 77 is 66. So that works, and we have a nice generic program that can function for us. We could even wrap this in a do another, and the person could use it multiple times. So that's an example of using a for loop with a break. Another thing that we could do is use a continue for another use case. So let's create a program called for loop with continue. And let's say that what we want to do in this instance is find all numbers divisible by 3 between 0, or let's make it more interesting. Let's say between 5 and 55. Okay, well, what we'll need to do is we need to make a for loop. And so let's say for I in range, just to see if this works, we'll put 5, 55, and just try to get that range to display. Print, and we'll print I. Notice how when we're trying to attack a problem like this, we start off with, just trying something, and attack one piece of the problem at a time. So let's see. Yes, we're able to display the numbers from 5 to 54. Okay, so that's the first part of the problem. We display the numbers between 5 and 55. The next thing we want to do is find all numbers divisible by 3 between them. So let's do this. Let's print I, and then let's print I mod 3, and we kind of need a space between them, otherwise what will happen is we won't be able to see what's going on. So we'll put a couple spaces between them and see what that does. So we'll run that. And now what we get is we see that every time it's divisible by 3, we get a 0. Every other time it's something else. So we can use that here. We just want to see the numbers divisible by 3. Now what we could do is we could say if I mod 3 print that. This would be one way of doing it. And you can see, well, if I do that, then I get all, right now I'm getting all the ones that are not modulo. So actually I need to check to see if this equals 0. And now we can see that we are displaying just the values that are divisible by 3 and that have a modulus of 0. So now what I could do is I could get rid of this, and that would display just the values that are divisible by 3, which works very nicely. But let's say that I wanted to put this into a string maybe, and then display it all at once at the end. So what I could do is I could say a result is equal to an empty string, and what I'm going to do is I'm going to say result plus equals, and I'm going to convert I to a string, and then I'm going to add maybe a comma and a space after it. Actually, I'm going to call it result str. I think that will work better. Well, what I'm going to do here is I'm just going to do a continue. So what's going to happen here? So what will happen here is as I go through here, and then what I'm going to do is I'm going to say if it's not equal to 0, then I'll continue. So what this will do is it'll check to see if the number is not divisible by 3. If it's not divisible by 3, then we're going to continue on. What that means is it's going to skip all the other statements that are at the end of this block, and it's going to go and run the next one. And every time there's a one that's divisible by 3, it won't do this. It'll execute this piece of code. It'll concatenate I as a string to a curly brace, and then concatenate it to this string. And then at the very end here, I will print result string. So let's try that, see what that does. And there we go. We have the numbers all concatenated together, and we have our all the numbers less than between 5 and 55 that are divisible by 3. And we use the continue, and we can watch this happen. I'm going to put a stop point here, and I'm going to run in debug mode with F5, pick the Python debugger, and let's see what happens. So here we are. We're at this point. We're going to step over 1. I is now 5. Is that divisible by 3? We're going to step over 1 more. And so I mod 3 is not, right now it's 5. 5 is not divisible by 3. So what we're going to see is this continue is actually going to send us back. It's not going to execute line 7. It's going to go back up to 4. Now I is 6. 6 mod 3 is 0. So that means it's not, this is going to fail because we're looking for not equal to 0. That means that we're not going to do the continue, and instead we're going to take the result string, which initially is just an empty string, and now we'll have 6 comma added to it because we converted 6 to a string and then we added a comma. So now that's our result string. Now we have I as 7. That's not equal to 0. It's going to do the continue, which means it's going to skip line 7 again. Come back up here. I is equal to 8. That also is not divisible by 3, so it's going to skip. It's going to continue, which means it's going to go to the next loop. We're now on 9. When it hits 9, this will fail. It won't do the continue. Instead, it will do this statement. And so you can see it's going to skip, skip, and then add 1. Skip, skip, and then add 1. So this continue is a way of skipping over the rest of the block of code for the for loop so that you can go on to the next one. This also works with while blocks as well, and is a very useful statement for certain types of scenarios like this one where you want to skip until you get to the right one and then do something with that. I'm going to skip through the rest of these by putting another stop statement here, and if you click on the continue statement, I'll take this one, I'll hit continue, and it'll run through all the rest of the codes, and then we get our result string, which is what we're looking for. And do the print, and we're done with the program. So that demonstrates how we can use the continue statement.